Here we go, page 2. It's 4:07. My lights are still off. So hopefully this doesn't take too long. These are just going to be, are the triangles congruent, yes or no? How do you know? If they are congruent, tell me how. And then of course list them out. Now on this one, we have here, we have 60-degree angle, we have a 55-degree angle. So we can use a little bit of math, just a little bit, to figure out what angle MHA is. 60 plus 55, that's 115. So 115 plus 65 gets us to 180 degrees. And for that same reason, we know that angle T has to be 60 degrees. Now I know what you're thinking. Angle, 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 that's no good. All right, and I agree. All right, but we have some extra information. We have a shared side. All right, we can assume that that is a shared side. AH is congruent to AH. That's the reflexive property. So these triangles are congruent. So we know MAH. All right, we have to be careful going from MAH. M is a 60-degree angle. Well, T is also a 60-degree angle. But we have to be careful because A on the first triangle is a 55-degree angle, but A on the second triangle is a 65-degree angle. So you want to match up, you want to go with the 55 has to go with the 55. So it's actually going to be H. All right, and then we're going to finish up with the A. Okay. Now there's actually two reasons for this one. I could say either angle, side angle, or we could say angle, angle, side. Both of those would be correct for this problem. All right, and that's all we got. Next, number 13, triangle LOE. Is that congruent to something else? Well, let's see here. We have a shared side. We can always assume shared sides are correct. All right, so EO is congruent to EO. We have a corner. That means this is a 90-degree angle. Anytime we have a 90-degree angle, all right, that should be kind of an indicator that you should use hypotenuse leg. And in this instance, we do have a HL situation. All right, so anytime you're looking at the side that is opposite or across from a right angle, from a 90-degree, that is what you call the hypotenuse. All right, the other two sides are legs. It doesn't really matter. We just call them legs. We don't have special names for them. So this one is HL, right? LO is the hypotenuse. VO is the hypotenuse. And then EO being congruent to EO, that is the leg that they have in common. So the only way this one works is HL. So now we go LOE, that is going to be VOE. All right, and that one's done. Next. 14, we have some parallel lines. We know some sides are congruent. So here's what we got. We got some vertical angles. All right. Now, keep in mind with parallel lines, so these lines are parallel, we have a transversal. So what we can say is that we can say those two angles are going to be congruent. All right. And we also have another transversal. See, I already messed up. I'm going too fast. All right. Take 2. 14. All right, so we have this transversal. So we know angle P is going to be congruent to angle S. Okay, angle P is congruent to angle S because those are parallel lines. All right, we also have another transversal up here that looks like this. Angle O is going to be congruent to angle E. All right, now this one, kind of interesting. Let's see what we got here. Is this one congruent? A lot of you might be thinking, yeah, this one's congruent. But I disagree. I don't think this one is, because if you notice, if we think about ASA, all right, if we look at ASA, let me just write this down. ASA. Notice how we have a red angle and an orange angle. But if we look at the left triangle, SCA again, but we have a red angle and a blue angle. So those angles are not lining up. All right, so that is incorrect. So let's see here. Maybe you're thinking, well, what about angle, side? That is another possibility. And normally I would agree with you. So we would have angle, side like that. So we got the blue angle and the red angle. But if you look at the other one, we have an angle, side. We have the orange angle, the red angle, and the side. Okay, so it's like if you look at the left triangle, that would be like an ASA. And if you look at the right triangle, that would be AAS. So this one actually does not work. All right, so you can't say like, oh, the left triangle is ASA and the right triangle is AAS. They have to be the same kind of thing. Those corresponding pieces are not matching up. All right. Now number 15. Number 15, we have triangle ACD is congruent to something. C is the midpoint. What do midpoints do? Midpoints cut segments in half. All right, C is the midpoint of BD. All right. We have our reflexive side, and then we know AB is congruent to AD. All right, so this one is SSS. So now let's just go in the correct order. ACD is going to be congruent to ACB. All right, so that one's fairly straightforward. I think the sides are the easiest ones to kind of pinpoint. And remember, the midpoint lets us say that DC is congruent to CB. All right, midpoint cuts one segment into two equal pieces. All right, next we have a shared side. All right, I didn't even look at any of the given information because I don't know, my eyes immediately went to that shared side. So we know AE is congruent to itself. Now the next one we have is GE is perpendicular. Remember, what does perpendicular mean? That means a 90-degree angle. So if GE is perpendicular to AG, right, we're going to have a 90-degree angle there. All right, we have another perpendicular. EM is perpendicular to AM. All right, and the last thing they give us, GE is going to be congruent to AM. So you got to think, which one is this? This is hypotenuse leg again. This is HL. AE is the hypotenuse. GE is a leg. AM is also a leg. So GAE. So let's think GAE. G is the right angle. So we need to start with the right angle when we're kind of listing the order here. So let's start with an M. All right, then we're going to A. So G to A, and then we're going across the hypotenuse. Notice how GA does not have the tick mark on it. So if we're going from G to A, if we look at the other triangle, we have to go from M to E. All right, because ME does not have the tick mark on it. And then we're going to finish up with G. We're going to go up to G. So MEG is going to be congruent to GAE. All right, next, number 17. We have vertical angles right here. All right, so we can say that those are congruent. AD and BE bisect each other. Okay, that is important. That means both of these we can say are congruent. So AC is going to be congruent to CD. We know BC is congruent to CE. Now, if it said AD bisects BE, we could not assume both of them. But since it bisects each other, then we are safe. All right, so this is an SAS triangle, and then we're going ABC. That is going to be DEC. DEC. All right. Next one, I think there's 3 more here. TZR is congruent to something. So TS is perpendicular to ZR. So angle 3 and angle 4 are 90-degree angles because that's what perpendicular means. And then they're telling us Z is the midpoint of TS. All right, I agree. And then we also have this shared side. Okay, so it's a right angle, but this one is not HL. TR is the hypotenuse, SR is the hypotenuse. We do not know if those are congruent, right? That's not part of our given information. So this is going to be one of those ones where it is a right angle, but it turns out it is side angle. Side is the SAS theorem. So we're going to go TZR is going to be congruent to SZR. All right, that one's done. Two more. Here we go. JME. Okay, we had one very similar to this on the homework. This probably has to do with JME, these overlapping triangles. All right, so JME is going to be this blue one, and we're going to have this red one here. We got to see if those are congruent. Do we have enough information to say that these are congruent? So here we go. I'm going to split them into their respective pieces, and then I'm going to label them. So let's see. We had our J, we had our M, we had our E, and then red one we're going to have MAS. MAS. Okay. So we know MA is congruent to ME. All right. We know J is congruent to S. All right. So now this is where we have to get a little creative, because keep in mind we pulled the triangles apart, but we still have kind of these points on here that kind of go away because they're no longer intersecting. So point A, that green point A there, it's still kind of there, because when we overlap these triangles, right, it's still there. We just kind of ignore that it's there for a little bit for the time being. But keep in mind, both of these triangles still have this angle here. All right, so they both have this angle in common. So this one is an angle side. So we know JME is going to have to go with SMA. All right, and I got one more for you here. So we have these lines are parallel. That's all we know. AB is parallel to DE. We can assume that these are vertical angles. All right, what do we know about parallel lines? Parallel lines make congruent angles, not congruent sides, but congruent angles. So we know angle A is congruent to angle E. All right, we have another one. We can say angle B is congruent to angle D. Okay, so that's all we know. All right, all we knew were those lines are parallel. We don't know anything about midpoints. We don't know anything about AB and DE being congruent. All we know is that they are parallel. So this one, if you're looking, is just angle, which is no good. All right, so this one is also a none. Big old fat none. All right, so we cannot do that. All right, so all of these pretty straightforward except for this one. Right, so this one was a little bit of a curveball. So hopefully I explained that one to your satisfaction. If you have more questions on that one, then we can talk about that one later. But I will see you guys in the next video.